we focus on hardware development, things like programming Arduinos, Raspberry Pis, as well as dealing with 3D modeling and 3D printing. Hopefully next semester we are back in person. I know some of the classes are all virtual, but if they do come out with the vaccine and they do allow us to go back on campus, definitely Make is going to be at another level. We have a lot of stuff that we've ordered for the program. So as an example, I think we ordered 30 Arduinos and 30 Raspberry Pis. We have a new Form 3D printer, Formlabs 3D printer, which uses the actual liquid to make that printing type of stuff. So we'll have that in the space. If you haven't ever been to La Villa, I definitely recommend you go. And it's somewhere where you could always chill. Usually back in the semesters where we were on campus, we would always just be playing Smash in there or working on different stuff. Or if you ever need to print something or you just want to maybe work with the equipment that we have there, we're more than happy to help you with that stuff. Yeah, so my first semester wasn't as pleasant as I thought. Yeah, it definitely was not ideal, but trust that things will get better. You just got to stay hopeful, right? And you always try to see the better light in things. As much stress that I've dealt with through my whole college career, trying to keep that positive mindset has helped me get opportunities. And it might be luck, it might be all the work that I've done. I've definitely gotten a lot of opportunities that I never thought that I would have gotten. It's definitely a dream, so stay positive for sure. But yeah, so all the workshops for this semester are over. This is the last one, but definitely stay tuned for when we release the workshops for next semester. Like I said, there's going to be a lot cooler things. We have a lot of cool things planned. We're going to start doing collaborations with all the other programs within UPE. We're going to start talking a lot more with other organizations and doing things with them. In the beginning of the semester, we did do something with SHEP. Hopefully, we continue that collaboration with them and bring you guys a lot more content, whether that's professional development or technical skills as well. This is an old slide, but the e-board positions are already closed. But if you do want to become a committee member, whether that's for Make or any of the other programs, the committee applications should be opening in a few weeks. So stay tuned for that. That's how I first got involved. I became a committee member for Make, and then the next semester I became the director. So it's definitely not hard to get a position and become involved. It just takes passion and drive and that type of stuff. You have an e-board at 8? Bro, you're fine. Don't stress it. It's not that scary. Just, talk about what you know, talk about your experience, show that you have passion for whatever it is that you want to do. And you should be good. If you maybe have any questions for me after, maybe I could give you some pointers in terms of maybe what to talk about. I guess, yeah, I could say definitely talk about if it's for the Make director, talk about your passion for hardware, and things that you've done with hardware and that type of stuff. But yeah, if you haven't joined the Discord, make sure to join the Discord. I'm gonna try to go a little bit fast because I don't want to keep you guys here for over an hour for sure. If you don't know our social media, this is our social media. Make sure to follow and use the hashtags if you ever want to. That's definitely, I guess I'll tell you guys a little bit of a story as well. That's kind of how I first tried to let the e-board know that I had passion and wanted to be a part of it. So it was last Shell Hacks. I had 3D printed a logo that said Shell Hacks 2019, and then I posted it on my Instagram and I tagged them. And then they reposted it. And then I went to go see the director and I'm like, hey, look what I made. And then that's kind of showing him, oh, look at this guy. He printed something that says Shell Hacks on it. So it shows that you are going out of your way to create something that's pretty cool. But anyways, so this is a Raspberry Pi Pong workshop. So we're going to be using potentiometers to create the effect of a Pong game. And we're also not just going to be using a Pong game. We're also going to be creating an oscilloscope. We're also going to be showing you how the ADC value is converted to voltage. And we're also going to be creating an ellipse where we can manipulate the width and the height of the ellipse with the potentiometers. Now, we're going to be using the Raspberry Pi. Raspberry Pi has multiple gigabytes of RAM. It has an Ethernet port. For the most part, you shouldn't need to use the Ethernet port because it does have a Wi-Fi module. You would use an Ethernet port for maybe an older version of a Raspberry Pi. But this is a Raspberry Pi 4. What I would say from this slide right here is that the Raspberry Pi doesn't come with an ADC converter or an ADC chip already in it, which is why we're going to be using an ADC it's called a PCF 8591, I believe. An Arduino, as an example, has an ADC converter already built in it. So if we wanted to do this same workshop with an Arduino, we wouldn't have to buy that separate device. So why use it? Raspberry Pi is really small. It's basically another computer. So if you want a computer that you maybe don't have and you want to pay a little bit, you could get a Raspberry Pi. I've seen a lot of cool things that people have made. If you've ever seen those smart mirrors that could be made with a computer, or the Raspberry Pi, drones, RC cars, all that type of stuff. I think I mentioned it maybe at another workshop, but something that I'm using a Raspberry Pi for is my senior 1 class, where we're creating an OBD2 connector that connects to your car, and then it uses Raspberry Pi to take those readings. So whenever you get the check engine light, our device is going to be able to connect to your phone and show you all those codes. It's also going to give you information about the GPS or like the location of the car, whether someone may be bumped in your car, and then they'll send you a notification to your phone. So like as an idea, that's some of the stuff that you could do with the Raspberry Pi. It's really cool. And then we also, I don't know if we're going to get this far, but we also want to add a camera and have it show video whenever the car gets bumped and stuff like that. So there's a lot of things that you could do with the Raspberry Pi for sure. It's a really cool device. Some of the GPIO pins, we're going to be talking about the protocol communication buses because we are going to be using I2C for this specific workshop. But I'll also mention to you some of the other protocols that you can use. You have the transmission and receiver pins, which are these right here, GPIO 14 and 15. They're part of the UART protocol. They're a serial link, and it's probably the worst of all the communication buses, because if you want to add more devices, you have to add external, I guess, circuitry to it in order for it to work. The I2C is probably the best one out of all of them because it's while it's not as fast as SPI, it does make it so that if you want to use multiple devices, it's very easy to do that. Give me 1 second. Okay. So you also have SPI, which is similar to I2C, in that you could connect different devices and communicate with those devices. And then what these two protocols use is a clock. So what that allows you to do is have it be synchronized so that you can send data to these different devices in a sequence, basically. Now what we're going to be learning today is the different protocols. We're going to also learn how the PCF 8591 chip works. We're going to go over a Java overview. If you don't know Java, you're in the right place. We're also going to be looking at the processing graphic library. Processing is really cool because it allows you to create very visually pleasing applications very easily. And then we're going to be creating different programs using that ADC chip and using that potentiometer. And lastly, we're going to create a Pong game. Starting off, these are some of the terminal commands that you can use with the Raspberry Pi. It's not going to be something that we're going to be using a lot in this workshop, except for maybe sudo Raspberry Pi config, so that we could turn on those protocols or the communication buses. But other than that, whenever you do have a Raspberry Pi, it's always recommended to update it and upgrade it before you start using it. But those do take a while to upgrade. So if you don't have a lot of time, maybe leave it for later. If you haven't gotten a VNC viewer on your computer and you want to connect your Raspberry Pi from your computer instead of connecting it to a monitor, you could follow these steps. Or you could also SSH if you want to connect to the Raspberry Pi from the terminal. Now to talk a little bit about the protocol communications. There's 3 of them that are specific to be used with the Raspberry Pi GPI opens. Those are UART, which is Universal Asynchronous Receiver and Transmitter. I kind of talked a little bit about all these, but we'll go a little bit more in depth now. So SPI is a serial peripheral interface, and I2C is integrated circuit. This is a diagram of kind of the way that they're connected. So for UART, you have 1 pin for the transmitter and 1 pin for the receiver. Similarly, with the device that's receiving that, you have a receiver and a transmitter pin. For the SPI, the way that you're able to use multiple devices is with these 2 pins that it could be a lot more. I think it's only 2, but these allow you to select what device it is that you want to access. And then MOSI is from master to slave in terms of the device, and MISO is from when you're going to a slave to when you're outputting data from a slave device. So yeah, UART is asynchronous. What that means is that it doesn't, the data that's transmitting isn't happening at the same time. So it's receiving and transmitting data not at the same time. You have to do one in order for you to do the other. But it is bidirectional, so you can transmit and receive from both the device and the Raspberry Pi. And yeah, we also have a SPI, which is full duplex. So what full duplex is that it allows you to, I believe it's, so it's communicating not synchronously. It means that you can transmit and receive at the same time. Unlike this one where it's asynchronous, SPI allows you to both transmit and receive at the same time or synchronously. You do have to use 4 pins for this, since you have the selection line as well as the lines that are when you're sending data from the master device to a slave device, and when you're sending data from a slave device to another slave device. And as you can see here, master in, slave out, where this pin is sending data to this device. Yeah, and usually these are used for short distance devices or short distance between devices. For I2C is half duplex. What half duplex means is that it's only sending data in one direction at a time. The cool thing about I2C is that there is a limitation to how many devices you could connect to it. And it also allows you to connect these devices very easily, since you're only using 2 pins. But since we're using 7-bit address, then that gives us access to 127 devices that we could connect to it. Now the I2C does use 2 pins. One of them is for the clock cycle. So this ensures that there is synchronization between the transmission of data, and then you have the data line, which sends bits and also receives bits. And yeah, it supports multiple devices without using additional hardware. So now I'm gonna show you guys how you can turn this on with the Raspberry Pi. So if you have your Raspberry Pi and you want to follow along, go for it. If not, then just pay attention so you could learn how to do this if you ever have the chance to. And then we're also going to show you how you can check to see. Let me change the camera so that you can see my Raspberry Pi and the thing that we're going to be using here. So this right here is the ADC chip. This is what's going to allow us to take the reading from the potentiometers that are analog signals and change them to digital. Since the Raspberry Pi only takes digital signals, where you're going to be using the ADC chip to change those values, basically. Now, how we're going to be communicating with this chip is using that I2C protocol. So now that I turned it on, I'm going to connect to it using the VNC. And then the good thing about, I mean, at least for this workshop, is that all the sketches that we're going to be using, for the most part, are use the same circuitry. I am still going to explain to you how this circuitry is connected once we look at the diagram. But yeah, so starting off, if you do sudo rasb-config, and then let's see, let's put this right here, put that there. So we're gonna go to interface options, and then if you wanna, so we're not gonna do, I'm gonna show you how to do it, but we're not gonna do all of them. So for UART, you go to serial port and you enable it. In this case, we're not using it, so I'm just not gonna enable that for now. For SPI, we're gonna go to interface as well. And then SPI says it right there, P4. Enable it as well if you're gonna be using that. In this case, we're not, we're gonna be using I2C. So P5, would you like the ARM I2C interface to be enabled? Yes. Just because I think it might make me reset, I'll go ahead and put, oh wait. Yeah, no, it's fine. Yeah, so we enabled I2C, so now it should be enabled. Now, if I want to check to make sure that the device is reading and is being sent by those two pins, or those the I2C pins, let me show you again. So these pins right here, and you can see them that they're connected right here as well. These connect to, because they have to go through a resistor, but after that resistor, they go directly to the chip, and the chip has two pins that say SCL and SDA, SCL for the clock, SDA for the data. So, but I'll show you the chip later on. Oh, all right, where are we? Is that where we're at? No. Okay, we're here. So how do we check to make sure that it is recognizing that device? So what we do is type I2C detect -y1, and then it's going to check all the locations, the address locations, to see if there is a device connected or not. Oh, I don't have mine connected because I haven't given it power. So what I'm gonna do is I'm gonna close that. I'm gonna connect it, give it power. So in this case, the power that it takes is, I believe it's the 5 volt. No, it's the 3.3 volt. Yeah, that's my bad. Because as you could, we haven't gotten into it yet, but it says it here as well that it operates from 2.5 to 6. So let's open up the terminal again. I2C detect -y1. And you can see that we have an address of here 48. And the way you read this is going down 40 and then going to the right 8. So then this is showing us that there is a device connected at this address. So then this is how we're going to access that bus and be able to communicate with the ADC chip. Yeah, so then the PCF 8591 ADC chip, it uses the I2C bus system to be activated and sends a valid address to the device. And then on the chip itself, you have pins A0, A1, and A2, as you can see right here on the left. And these are the ones that are going to be used to take that the analog read signal from the potentiometer and send it through these pins right here, the SDA pin. so that we could then send that to the Raspberry Pi and create cool stuff. But since this chip is an 8-bit ADC that gives us a resolution of 0 to 255. I don't know if you guys remember, but when we did the Arduino workshop, the Arduino has a 10-bit ADC converter. So I believe the resolution for that was from 0 to 1024, around there. Um, so yeah, in this case, we're not going to get as much of a resolution. If you have more bits, you're going to get more accuracy, basically. But this is going to be enough for what we're trying to do here. And yeah, this is kind of an example, or diagram of how the ADC is working. So you have this analog signal, right? And then it's taking different points within that wave and then converting it to digital signals that you could then convert into like zeros and ones, and depending on um, the duty cycle, have that be um, that the signal that we're trying to get for the program, basically. But yeah, for the Java that we're going to be reviewing here, for now I'm going to put the camera back on me. But so yeah, so a little bit of overview on Java. Java is an object-oriented program. So it being an object-oriented program, an example of that would be a dog, for example, or a cat. And these dogs and cats can have different characteristics. That's what the states are. And then you have behaviors, and the behaviors are the different actions, or in CS terminology, the methods. But with an object, you create an instance of a class with that object. And what a class is basically a blueprint. So the behaviors and the states of an object are included within that class, and then whenever we create an instance of that class, or an object of that class, then we're going to have that blueprint, and we're going to be able to manipulate those characteristics of whatever that object is. A little bit confusing, but we'll show you a little bit of some examples. You also have methods, which is the logic of it, and you have instance variables, which initializes different, I guess, characteristics or values to the specific object. So some of the syntax with Java, you do have to declare the type. Here we're declaring the variables a, b, c as integers, but we could also initialize the value of that integer or that variable. You also have byte, you have double, if whenever you want to use decimal places. You have char if you want to use a specific letter. You also have if statements, similar to how we covered with Python. You have your condition, your statement, your else if, and then your else if neither of these conditions are met. This is an example. As you can see, 3.5, 3.4. If it's greater than 0, it's a positive. If it's equal to 0, it's a 0. And if it's neither of those, then it's going to be a negative. You have your for loop, which is basically going from 0 to 10, and each step is incrementing by 1. And then you have your advanced for loop, which is the same as a for loop. The only difference is that you're using an array, and you're using the data type item to take that value from each specific element within that array. If that makes any sense. If you need any clarification, make sure to just type it in the chat. Maybe I could explain to you if you need that explanation. And then this is what a class looks like, right? So you have public class. In this case, this is the name of it. And then within within your first Java program or your class, you have your main method, which is what gets executed initially. So this is where the whole program starts, basically. And this is a statement that prints hello world. But we're going to be using the processing development environment for this workshop, which is going to allow us to create different graphics for the program that we're going to be using. If you don't have a Raspberry Pi and you want to follow along to some extent, now that extent is not very far if you don't have a Raspberry Pi, but you will be able to get a sense of how processing works. Maybe create a circle, create a window, change the colors of that window of the circle. Maybe make a rectangle and have that rectangle move around with your mouse, which we're going to do, and we're going to show you that. You could go to this website and download it on your computer. If you're on Raspberry Pi, then you could type this command into your terminal and it will download processing for you. So I'll show you how you could, I'll basically type it, but I won't execute, or I guess I'll execute it, it's fine. But I already have it downloaded. Hopefully this doesn't mess anything. It shouldn't mess anything up, but. And it should go pretty quick since I already have it downloaded. Anyways, let's go on to the next slide. So yeah, we're gonna create a program using processing. The cool thing about processing is that it has pre-built methods already in place, so that it's very easy for you to create different graphics. Like you can see, just in case I'm gonna close this because I don't want this to mess up my workshop. It probably won't, but better safe than sorry. If you haven't done this, then just go ahead and do it. But yeah, so as you can see, you have size, which will create a window of your program with 800 by 600, where the parameters is the length and the height. You also have background, where you can have the background be any color with that integer that you're placing, which is from 0 to 255. You could also use RGB, so you could add 3 different variables within that background parameter. If you want to use those RGB colors and maybe have it more red than green or whatever it may be. If you want to create an ellipse, all you do is call the ellipse, and then the first 2 parameters, or as you can see here, as well as rectangle, the first 2 are going to be the X and Y coordinate of that shape within the program window, and then the other 2 parameters are going to be the width and the height. So let me show you that really quick. Again, you could follow along with this part, and then probably let me show you really quick while this is loading, some of the cool stuff that you can do with processing. This guy, the coding train, genius. Let's see.
Do so, but the calculation from -1 and 1.
Yeah, so this is all done with processing. Obviously, it's gonna be somewhat complicated when you're creating these types of effects, because you're using numbers and functions to create this type of effect. But it shows you kind of the type of stuff that is possible with it. But to be a little bit more, I guess, beginner friendly, all we're gonna do is first let's create an ellipse, or let's create the size, where the size is gonna be 800 by 600. Make sure to have that semicolon at the end because we're using Java. And as you can see, it creates an 800 by 600 window. Now, if we create an ellipse, where we're gonna define its location and then its width and height, we're gonna create an ellipse or a circle at that location. So now the coordinates start from the top left. So if we're going 50 to the right and 50 down, so it's gonna start from this point, which is 0. I'm gonna go 50 to the right and then 50 down. So if I were to change this to 400 by 300, which should be in the middle, it should place that circle within the middle. Yeah, basically. And then we also have background, which you can use if you want to change the color of the background. I believe 0 is, I think it's white or black, but 255 will be the opposite. Yeah, so 0 is black and then 255 is white. Cool. So then the thing with processing, it's kind of similar to Unity and C Sharp if you've ever programmed with Unity and program games, but you have your initial method. These are predefined methods that processing allows you to use, where the setup is going to execute once, and then the draw method is going to execute every frame. So by default, whenever you're using processing, it's going to be running at 60 frames per second. So every frame within those 60 frames, this method is going to execute. So now what exactly this is doing, so we're going to set up, we're going to create this setup method, which is going to execute for, I guess, yeah, once. And so this size 800, 600 is creating that window. Obviously, we don't want to create that again and again, because then we're not going to be able to see our program at all. But what we could do with the draw, with that draw method that executes every frame, is we create a background, and we're gonna make it black, and then we create a rectangle. Now, processing gives you predefined variables. Two examples of that would be mouse X and mouse Y, where it will take the coordinates of your mouse and send that to that rectangle method. So as you could assume, what this is going to do is that is going to move the direction of that rectangle according to your mouse. And then the length and the width of the rectangle, we're going to make it 200 by 100. And if this works correctly, yeah, we have a rectangle that's moving according to my mouse. Now there is a little bit of lag because obviously I'm using a remote desktop viewer. So if I were probably connecting my Raspberry Pi to a monitor, then it would be a lot cleaner, basically. But the reason that we're getting this effect is because at every frame, we're again initializing that background to be black. If I were to not do this, then it would create as many rectangles as I would go around, because every frame it's creating a new rectangle. But and then also lastly, there's also this line method, which we're going to be using for when we create the oscilloscope. Windows XP days. Yeah. Can you paste the command? Freak. This command? Yeah, this command. There you go. But if you don't have internet on your Raspberry Pi, then you can download this on USB or something, and then, USB, and then put it into your Raspberry Pi. If you don't have Wi-Fi, but you should. And then yeah, so the line method is gonna be something that we're gonna use for when we create that oscilloscope. Since with an oscilloscope you have waves that are created with lines, where the first two parameters are going to be the x and the y coordinate of the first point, and then the other two are the second point, which obviously creates the line. But yeah, so starting off, we're going to, if you need me to slow down, if any of you are actually following along, then let me know. But if not, then I'll just continue, and then hopefully you guys, are getting something from this. But yeah, so for this first sketch, what I'm gonna do first is show you guys how you create or how you could read the schematic and then create the schematic on your breadboard. I tend to follow this a little bit more than this, just because the chip here doesn't really tell you the pins that we're connecting it to, while this does tell you the pins that we're connecting it to. And these, as you can see here, these two are resistors, which are going to be a 10K ohms. And this right here is actually a potentiometer that we're going to be using to, create that analog signal. But let me then, in this case, really quick, switch this camera to view my board. And then I'll try to explain it best I can, along with the diagram that we have here. So make sure to pay attention to the screen as well as the camera. as I try to explain this to you. So first of all, I'm just gonna disconnect the power because I don't want to have any issues with that. But first of all, we have the SDA and SCL pins, which are going to be those two on the top left, from one down from the top left of the Raspberry Pi, and then those are going to go directly into the two 10k ohms, 10k ohm resistors. So then I don't know how well you can see this, but here you have one connecting to the one resistor, and then you have, which is the green, and then you have the purple one, which is also going into the other resistor. From there, they are also getting power. So if you have experience with a breadboard, the way that they work is that these two lines on the side, one is going to be positive and negative. That's the easiest way to distribute your power to different parts of your circuit. And then so we're taking that power trail and then adding a circuit that goes to those two resistors. So these lines on the side go all the way down, and then the ones in the middle go side. So then this right here is, yeah, it's really hard to see, but I'll try to explain it best I can, and hopefully you guys can see somewhat. But yeah, so then from there, we have them connect to the pins on the chip. So then let's see what we're doing here. So we have our green that goes to connected to one of the resistors, and then we have the yellow, which is also connected within that junction. Junction being that point where all those 3 points are connected um, to the circuit board. So then that yellow cable is going to go to the SCL, which is going to be our clock. And then our purple, which also connects to the other resistor, is also connected to the white cable, which goes to our SDA, which is the data. And then, so that's what we have here. And then you also have to connect 3.3 volts to the VDD, which is going to be the thing that powers the chip. In this case, my VCC or VDD is going to be this blue wire, which is connected to this red. You can't see me. I think I'm getting the gist of it. Okay, cool. So yeah, so then this power trail connects to that VCC on the chip, and then what else? This is a little bit different from the actual chip that we're going to be using, but for the most part, it works the same way. So the VREF, we don't have that pin on this chip. If you got the one that comes with free zone, then you should be able to follow this exactly. But and then we also have the A in 0, which is connected to the potentiometer. Right here I have two, but I'm going to go ahead and disconnect one of them because for the first sketch, we're going to just be using one of the potentiometers. So that potentiometer is going to connect to the middle pin of the potentiometer, and then you're also going to make sure that you're powering the potentiometer by connecting another wire from the power trail, and then also on the other pin on the left side or the right side of the potentiometer to ground. Okay, that should basically be it. Hopefully I explained that well. If you do have any questions, let me know. If not, then we'll go ahead and get this demo started. But yeah, so for this demo, we're gonna have the voltage be shown according to that ADC value. I'm glad to hear that, Raul. And yeah, so like as you can see here, we have the SDA pin and then the SCL, and then you have your A in 0, and then you have your A out. We're not going to be using the A out because we're not going to be sending any analog. We're not going to be receiving. Yeah, we're not going to be receiving. Are we using it? No. Yeah, we're not receiving any data directly from the Raspberry Pi. Okay, so to give you a little bit of an overview, I'll just put this back on my face. To give you a little bit of an overview of the program that we're going to be using and some of the classes that we're going to be referencing. we're going to be using the class ADC device. This is a base class that has different modules specific to the chip that you're using. So in this case, we're going to be using the PCF 8591. But with this class, you have access to the analog read, which is going to be how we're going to read that value from the potentiometer. And then you also have detect I2C, which is going to give us the address and ensure that we're using the right device. If it doesn't get recognized with that address, then obviously it's not connected, which will return a false. But within this ADC device class, you have another class that extends it. So since this chip, it has a method specific to it, at like analog read, then we're gonna, once that address for the chip that we're using gets recognized, we're gonna use the method that is specific to that chip. Again, you could use analog write if you want to send a digital signal into an analog signal. But in this case, we're not going to be doing that. And then you also have the channels that we're going to be using, which you can tell from here, which will be 0 for A and 0, and if we're using 1, A and 1. So then let's go ahead and write this code. I'll put this over here, and then I'll make this full screen. This is unfortunate. Oh, whoa. Yeah, that works out, I guess. So yeah, first of all, we're gonna make sure that we, honestly, let me see how good I could talk while I code, because when it comes to this coding and talking and multitasking in that way, I'm not the best at it. But let's see. So first we're gonna create an object of that class, which we talked about, the ADC device class. And we're gonna name it ADC. And then within our setup, we're gonna first create our window, which is gonna be 640 by 300. 360, sorry. And then we're gonna check to make sure that we know what chip that it is that we're using. So the way that we're gonna do that is we're gonna access the method specific to that object class, the ADC device, to detect the I2C address. And then if you remember when I did that in the terminal, the address was 0x48. So then that's what we're gonna place there. And then if it is that, then what we're going to do is that we're going to create another object specific to that chip that we're using, which is the PCF 8591. The reason we do this is, again, because that chip has a specific method that can only be used for that chip. If we were to use the method that's for the other chip, then it wouldn't work. And then we're also going to check to make sure that if it's the other chip doing the same thing, then we're going to create a object for that one, which by default would be at the address 4B, hex 4B. And again, we create that object specific to that chip if that's the one that we're using. Um, 0x4b. Yeah, you know what? I'm gonna say it. This is gonna probably take a lot longer than I would like because typing while talking is not my fortune. So what I'll do is I'll pull up the example that I have and I go through the code. just because I don't want you guys to see me writing code and not really understanding it. I rather have the code there and have it be explained to you guys so you have a better sense of what's going on. Um, but definitely, if you do want to follow along, you have time to write it down. Um, but like as you can see here, this is the ADC the device class that I was talking about. Okay, I'll write it. Yeah, go for it. Write it, write it. Or also, actually, no. Um, if you don't want to write it, here, take this. I forgot I had this here for you, or for whoever was following along. I created a folder that includes all the sketches that we're going to be using, but I don't want you to just copy it. I want you to kind of understand what's going on. So definitely, like, pay attention, but so that maybe you could follow along and still understand. Where's my chat? But yeah, so then if it does detect this address, then we know that this is the chip that we're going to be using. So then we create this object so that we could reference those methods. If it doesn't recognize any of those, then it's going to say that the ADC module wasn't found, and then it's going to exit the program. And then what we're going to do here is that we're going to use that draw method that is going to execute every single frame. So this is how we're going to be able to access that potentiometer value using that specific chip. In this case, we're using the 0 channel, which is the one that we have connected on the chip. And then we're going to convert that to a voltage by multiplying it by 3.3 and then dividing it by 255. I believe they used, or the reason that we're using 3.3 is because since the chip that we're using is 8 bits and we're going from 0 to 255, that's why we divided by 255. Because if not, then we would get a value that's bigger than that, and it wouldn't work. And then we're going to make the background white. And then this is a method that we also are going to create within our program. But for this, we're going to make sure that we fill the background to be black. And then this is just like text methods that also processing gives you, so that you can censor your text and then give it a specific font. And then we're going to reference, or we're going to have that text display on our screen, and use that ADC value that we got from the analog read. And then we're also going to convert it to voltage. Now the plus NF, what that does, this is also another thing that processing gives you. It makes it so that you could add zeros on the left side or the right side of the value that you have. So that would be, I forgot what the name of it. It's like the decimal places or whatever. And then this is where it's going to be placed. This is the location. So this is the width, and this is the height. Width divided by 2, so we want it to be in the middle of the screen, basically. And then this is just information that we're displaying to the user, so that they have access to that for if they want to access it. So then let's go ahead and connect our device. We're gonna power it up. Raul, if you're following along, do you have the chip? Just so I know, or no? Do you have the ADC chip?
No, it's on the way.
Okay.
It's in delivery. Yeah, so I'm just trying to like write this down right now.
Okay, cool. Yeah, I just wanted to make sure, because if anyone was really, or like actually like following along, I would want them to. But either way, it's still a good reference since we're recording this. But yeah, so from this point on, I have it on. I have everything connected. I'm gonna go ahead and run it. I should probably show. Yeah, let me show you. So this is the program. So we filled the background to be white. We have the voltages in the middle, and then the ADC value. So let me show you my potentiometer. And as you can see, while I move this, we have the voltage decreasing and increasing. Remember, this chip, it goes from 0 to 255, which is or 8 bits, which is why when we go all the way up, we reach 255 or 3.3 volts, which is the voltage that we have it connected to from the Raspberry Pi. Now, if you look at the ADC class, you'll see that this is similar to some of the methods that we saw in the slide that I had showed you. But we detect the address, we begin that transmission through that bus, and we start to communicate to it, depending on if we find it or not. And then this is the specific for our chip. Yeah, bro. No, it's. I'm glad to hear that. That's one of the things that I wanted to do when it came to having make workshops. Every other semester it was always, how do you turn on an LED? How do you make it, you know, go up and down or be brighter or so? Can we theoretically use the ADC reader to control the object position? Yeah. Um, yeah, you can. I guess you'll see that when we do the Pong exercise. Since we're gonna be using those potentiometers to move the where the paddles are. But let's go back to the slide now. Um, and yeah, so this is the example that we had. Honestly, I might as well just explain it from here because it looks a lot better from here than it does from the terminal or from the Raspberry Pi. And then this is the other sketch that we're going to be using, where we're going to be able to change the diameter and the width, or it's not the diameter, the length and the height of the ellipse. Kind of like what you said about controlling the object's position, but in this case, we're controlling the dimensions of the object. So here we're again calling or creating that object for the ADC device class, so that we could check to see what chip we're using. Then we're creating the background, displaying the text, some user experience text, and we have the location, and we're making sure that it's in the center. And then what we're doing here in the draw is, this is a little bit more interesting, I guess you could say, because we're creating an array, and then we're storing those values from the two potentiometers. Since each analog read takes in the channel, we're going to be reading channel 0 and channel 1, which is A in 0 and A in 1 from that chip. And then, so here what we're going to do is we're going to check to make sure that the array isn't null, and if it isn't, then we're going to create that ellipse. Now, this is a method that we created, and we're going to be passing the values that we get from the potentiometer. And then this is where we manipulate and calculate those values to then use that ellipse method that processing gives us. So we're going to define the max diameter to be 280, so that when we do calculate it, it's being referenced with that. This is just information that shows us what that value is, or the X and Y value. And then what this is going to be doing is then manipulating it so that we keep it within that constraint of 255 by dividing it by 255. And you could check this yourself. So like, let's say for example, you have your potentiometer and it has a value of 100, since it could go from 0 to 255, and then we multiply that by the max diameter, which is 280. Now if we divide that by 255, then we get 109, right? So that's within that constraint that we want it to be, because we don't want it to be greater than 280, obviously. And then key press is a predefined method as well that processing gives us, that says whenever a key is pressed, if that key that is being pressed is one of these, in this case it's an enter, then we're going to do whatever is inside that method. In this case, we're going to be going to this website. Again, this is a really good resource if you want to try to play with different other different demos and projects that are available for the Raspberry Pi. Oh, and then now let me show you how that works. So this will be ellipse. So now, since we are using both potentiometers, I want to make sure that I connect the power back to the other potentiometer. And then I'm taking that A-in-1 and I'm connecting it to that middle pin on the other potentiometer so that we have both connected. So right now I have everything connected correctly, I should. So then if I go ahead and hit run, then that's my ellipse. And as you can see, as I decrease 1, the X goes down. As I increase and decrease the Y, the circle changes. I don't think, yeah, you guys can see very well. It's fine, bro. It's fine. You guys get it. You guys get the point. Oh, there. We can see the potentiometers. Okay, cool. And yeah, so that's the other sketch that we have. Now, hopefully you guys are kind of understanding how this is working, in that it's taking those values, calculating it, and then using the pre-made or predefined methods that processing allows us to use. Now we're going to create an oscilloscope. Now this specific sketch is a little bit more complex, I guess you could say. I will be going over the main methods and explaining to you some of the other methods as well, in some aspect or some detail. But first we're going to create an array, and then we're going to create how big or the length of that array. We're going to initialize as well switch to 0, and then hmult is going to be used for the zoom ratio. So if we want to zoom in or zoom out of the oscilloscope, we'll be able to do that with the keyboard presses. So the up key and the down key will allow us to do that. But again, the setup key is going to be used to initialize the program once, or initialize this code once. So then this is just defining the length and the width of the window, making sure we're using the right pin and creating that object, writing down some text on the screen, where you could use text align to make it be in the center. And then you could make sure that the position is where it is that you want it to be according to that width and the height. The width and the height are variables that are already also predefined from this call right here. So it's always going to be referencing those two parameters that you call with the size. And then analog count is going to be width divided by 2. So that's going to be 530 divided by 2. I believe the reason that they want us to use width divided by 2 is because since we're using an oscilloscope and we want it to show the signal as we are changing the potentiometer, if we were to create it to be the complete width, then we wouldn't be able to see the trail behind the wave, basically. So that's why then we create that array and initialize that value of that length. And then we initialize all those elements within that array to -1, so that we can make sure that the potentiometer, we're showing when we start it, basically, and when we're making sure that it only starts when we do have those potentiometers at a certain value. So then we take that the read analog from the potentiometer, and this is within the draw method, so it's going to be executing every single frame. And and then these are basically text that tells the user how to use the program. So volume, zoom up, zoom down with these keys. Space if you want to pause it, and then this is what's going to have this on the side be displayed. So we're going to be using a for loop, and then within that for loop, we use the text to then have that I value, which is going to be that for loop, go from 0 to 5. And then if I is equal to 5, then we also have a v character next to it. And then this horizontal line is what's creating these lines across the screen, as well as the vertical ones. Where again we have the first point of the line, second point of the x and the y of the first point, and then the x and the y of the second point. And then this is going to be preparing the actual wave data, which is a little bit not complex, but you will definitely have to calculate it yourself to understand how it is that these values are being created. But essentially, it's taking that analog data that we get from here, and then it's multiplying it by 500, and then that's what the voltage is. And then how it creates the actual line is with this for loop right here, where it's taking into consideration that h multi variable, so that if it is 1 or 5 or 10, it's multiplying that to be that, I guess, how would I explain it? Yeah, like it would make the line be greater or less depending on that multiplier. And then it's calculating it, and then here what it does is that it uses that line method to create that green line, and it uses this if statement to ensure that I'm going to be honest with you. I don't know what this is doing right here, but what I do know is that this line method is taking the value from this for loop and creating basically a constant from one point to another to create that value. And then key press again is going to take, if you press that up key, then it's going to increase. If it's already 1, it's going to increase it to 2. If it's 2, it's going to increase it to 5. And similarly with down key, it's going to do that same thing. And then for the space, it's going to pause it. And then whenever you do pause it, you want to initialize all those values back to -1. And then let me show you that now. Okay, I have it connected. And do you see how you see me? So as we increase the potentiometer, the voltage increases. And as we decrease it, it decreases it as well. Now it does, I mean, it looks simple, but it also, Flappy Bird with potentiometers. I don't, that would be a really, really cool project to do. I don't know how easy or difficult that would be with a potentiometer, but it would definitely be an interesting project. Maybe I'll try that for that clown hackathon that you're having. What is it called again? Wacka hacks? Okay. Whack hacks. Definitely. That would be a fun project for sure. And let me show you how when you press the key, the up and down key, it increases it. Yeah. So it's basically increasing the value if you press the up button, so that it's a lot more, I guess, not as accurate, or it's a lot closer to that value. Okay. And last but not least, we have the Pong game. So for this Pong game, it does use a lot of the same methods and variables that we went over. It's a lot easier to understand than the oscilloscope for sure, because we're not having to calculate that data in such a way to create those waves. This is a lot more self-explanatory in terms of what it's doing, and I'll show you this when we get to that. But to start off, we initialize the win score to 3. So whenever one of the players reaches that score, then the game is done basically. The acceleration is 0.5, so every time it hits a paddle, it increases in acceleration. We are using multiple classes and multiple files for this Pong game. If you click on that link that I did provide in the chat, you'll be able to see all the classes that are necessary. And essentially what it's doing is that the ball class is creating that ball, as well as initializing the speed. The paddle is creating those shapes of the rectangles that are going to be on each side, and is making sure that the position are always going to be at that point whenever you reset. But like the other sketches, we made sure that we used the chip by checking on the address, and then we give the background a color, and we have it with text, so that whenever the game starts, we have something that's being displayed to the user. We initialize the ball object, and as well as the paddles that are going to give it the size that we wanted, as well as the location. And then within the draw method, we're going to create an array that, like the ellipse example, we held those values within those arrays. Now this is going to allow this method right here, this if statement, is going to make it so that we can manipulate that position of those paddles by using this calculation here. So for example, if we were to have 100, now obviously we don't want it to go over or under the height that is defined by this size right here, which is 360. So if, for example, we were to have 150 as the analog read from one of the potentiometers or one of the paddles, and we were to multiply that by the height, in this case the height is 360, and then we divide that by 255, it's always going to be within that range of that height. And that's obviously something that we want, because if not, then the game would break, or it would be out of bound, and you wouldn't see your paddle. And then after that, we have the game states. Now, these game states are also part of, I believe it's the ball class. It's essentially making it so that depending on what the current game state is, we're going to be executing different methods. So for the welcome, is going to show a user interface that's a welcome to the user, and then it's going to display those two paddles. Now these display methods are specific to that class, so this just ensures that if we don't want something to be displayed, then we have access to that. So like for the welcome game state, we're not going to be displaying the ball, but when the game starts, we are going to be displaying the ball, and we're going to be calculating how exactly that ball is being, I guess, read from each paddle. You also have when the player 1 wins, and then when the player 2 wins, which displays information for that user. And now let's see something. So show GUI is just going to show us the some information that we're always going to have access to. So like the score that that each player has, and how we can maybe stop the game or restart the game. So that's what show GUI is. And then show info is also just showing information of how you could start the game. It's what is shown when you first start the game. I believe it's called, where is it? Yeah, show info. So it's basically just showing information for the user. And then calculate game, this is probably the most interesting part of it, because this is how it's understanding where the ball is on the screen, and when it's touching the paddle or when it's not touching the paddle. So if the ball is in position X and we subtract it by the radius because we want only the sides of the paddle and the ball to be touching, or the actual location to represent when it's being hit by the paddle or not. Um, so if the position of the ball is less than the paddle, and these are the X values, so from left to right, if the ball is less than, so let's say the ball is around here, or it's on the paddle, then that means that we need to do something. Whether that means have the ball go in the opposite direction or have the score increase. So then within that if statement, we have another if statement that checks the y and the position of the y for the ball and the paddle. So what that tells us is that if the y of the ball is up here, then that means that it's going to make it so that the other player gets a point. And similarly, if it's under, that's why you have an or. So if you don't know two lines within Java, that means or. If you have two and signs, I know they have a different name for it, but the and signs, and it's going to be that both of those conditions have to be met. In this case, as long as one of these conditions is met, then the score of the other player is increased. Yeah, exactly. Thanks, Ro. So then, as you can see, if the position of the y is less than the position of the paddle, that's if it's down here, then we're going to increase the score, and then we're going to reset the ball back to the middle. If it's not, if it's within this y, if it's in the same y as the paddle, then it's going to get the speed of the ball, and then it's going to increase that speed. And then it's going to save that speed for the next round, or the next time that the ball is hit. Similarly, it's going to do the same for the right paddle, and it's going to check to make sure that the x is greater than, because remember the x and the y is always in reference to the top right. So this is 0, 0. This is 320 or whatever it may be. This over here it would be 320 in the x, and I don't know, 100 in the y. So in that same aspect, we're able to take that position of the ball when it's on the right side, and then if it's under or on top of the paddle and it's touching the paddle or it's within the same x as the paddle, then we give the other player a score increase. And again, if not, if it's within the same y as the paddle, then we increase the speed, and we have the ball going the opposite direction. And lastly, we just have the key presses, which if we want to access the website, we press enter, and then if we press space, if we want to reset the game. And now let's show you that. And if you ever get bored, maybe want to play with your brother a game of Pong, then you're going to be able to do this with some hardware. So we're going to press space. Now, right now, it's pretty slow, right? But it works, right? Now, what if I want to increase the speed? We could go to the ball class, and we go down to initial speed. Let's increase that to 5. Let's save. And then let's run it again. And let's press enter. So player 2 got 1 point, 2 points. He needs 1 more point to win. Obviously, this is going to be a little bit laggy since I am using a remote desktop to access. And then player 2 wins. So yeah, pretty cool stuff, I would say. I think we definitely learned a lot of concepts, whether that was Java programming, processing. I definitely recommend you guys look more into processing. It's a really cool library for Java, especially for beginners. It's very user-friendly. But you could also do a lot of complex things like what we did here with the Pong game or with the oscilloscope and stuff like that. And yeah, that's gonna be it for the Raspberry Pong workshop. Is there still time? Can you do some code manipulation like changing the colors? Yeah. So, sure. So let's see what we can do here. Let's change the color of the ball actually. So right here we have the ball to be. Actually, I'm not completely sure what this color is because I think that right now would be black. But let's, for the sake of experimenting, let's just make it all 0. Oh yeah, it was a ball. So now we created a black ball. What if we let's see, what can we do? Let's make it RGB. Let's make it blue. And then let's also change the background because why not? So for the background, it's in the setup. Usually always is in the setup. Let's make that 156. Oh, actually the background should be in the draw because since the background is being rendered every frame, it wouldn't be in the setup, it would be in the draw. Yeah. But since we want to initialize it to be that color, that's why. So we made it a little bit lighter now. Oh, I'm ready for it. This is going to look either really cool or really ugly. So let's do RGB because that way we could actually get something as RGB. So that should be red, right? I think that looks pretty cool. Maybe make some Christmas colors. Change the paddles to green, maybe. RGB, RG, UPE colors. Isn't our UPE colors gold? The potential of a simple program like this. Not yet, for real. It's a orange gold. If you could get me that RGB color, I would be more than happy to change it. But I don't know it off the top of my head for sure. I actually think that they gave us that information, like the e-board, but I don't remember that. This is kind of hurting my eyes, to be honest. But I think it's cool nonetheless. Too saturated. Yeah, definitely. Like, think about it. You could make this ball a clown, or you could make this ball an arrow. Because with processing, you could create those different shapes. It's completely doable, and it's not really hard at all. There's a lot of tutorials online that shows you how you could create those different shapes. And different effects. You could create rain, there's a lot of really cool stuff that you could create with processing. You could take images, you could change the hue on it, you could make it be opaque, you could do a lot of things. Processing is such a useful tool when it comes to not graphic design, but creating graphics. You can even put the potentiometers into the slider or a big arcade game. Yeah. Think about maybe creating, I forget what that's called, but you know that game that has the two things on the side that's like with the ball in the middle? Do you know what that's called? That would be a really cool project to create. Foosball? No. Arcade game with pinball. Yeah, I bet you it's been made, but I don't know if it's been made with potentiometers, but it's definitely been made before. So imagine, oh wow, you know what just gave me a really good idea? I don't know how easily it would be to implement this, but imagine being able to create a browser game that has access to hardware. I don't think I've ever heard of anything like that, but definitely something to consider or talk about. I used to play that. Oh yeah, I used to play that game a lot, as well as Bomber or no Mine, the Mine game. That would be a great idea for browser with hardware integration. Yeah, I'm actually kind of curious about that to see if anyone's done that before. That would be a very very interesting project, but I wonder how hard or easy it would be to implement that. But like even maybe doing that would be an amazing and a crazy workshop, or not a workshop, a project to have on your resume. Maybe math visualization. Oh, let's do it. Let me actually. You said what? You said that should be a dark orange that resembles it. Impressive chess. Yeah, even that. So let's make the background be that color. Oh, nice. Yeah, that's a very nice color. I just hope, I mean, as much as I love Make and I've had a blast this semester creating all these workshops and presenting it to you guys, I hope that now I'll be able to maybe start working on my own projects and create these type of cool ideas that we've been learning over the semester. But yeah, if any of you definitely do want to get involved with Make, like I said, in a few weeks we're gonna open the committee applications. I highly recommend you get involved. It's been an amazing experience for me. I've met a whole bunch of friends. I've had experiences that I've never thought that I would have in college. I've had opportunities. It's really really something. But even if it's not with UPE, try to find a group, try to find something that you're passionate about, and it's definitely going to make your college experience a lot better.